Can we go over 51 from 3.5?
Bet. You bet, Claire.
Thanks.
So I'll hold off on this thing. And the reason I dragged this thing in today, so if anyone wants to know, so when it comes to, if you don't want to use quadratic formula, you want to use your grapher to solve it. Graphing calculator to solve, you know, a quadratic equation. That's why I brought this in. I know I talked you through last time, but I was looking around there, some people didn't have their PI. You see it up here. It helps the memory to kind of go. And you remember, 3.551. Inverse sine 2x plus 1? Oh, that's a great one. All right. Anyway, so before this, Sarah picked a good one. Inverse trig derivative. Y equals inverse sine 2x plus 1. Find dy dx. Inverse trig. Okay, we need chain rule, don't we? There's the g. What's the derivative of g?
2 prime 2.
So let's put a 2 in the numerator. Cool? All right, 2 in the numerator. And we can do this from memory, Claire. This is the one with the radical, right?
Right.
We got a radical. The cosine does the negative. This is the positive. And we write in the radical 1 minus whatever this thing was squared.
The book had something different. I think that's why I was confused. Because
So Claire did it right.
I wrote that, but the book had something really weird.
Claire got it right. She's saying, she goes, but the book did something weird in the back. We're going to figure out how they wrote it that way. First of all, pretty good, huh? That's it. There it is. There's derivative. 2 over 1 minus 2x 1. Now, if this was just 2x, I know you could get in your head, everyone. What's 2x squared? It'd be what, 4x squared?
Mm-hmm.
But the book did something different. So I imagine they expanded this.
Mm-hmm.
Let's start with that. All right, so we'll just keep doing an equal sign. How did the book write this in? All right, let's FOIL that 2x plus 1. All right, what do we get? 1 minus, let's keep a parentheses around that. 4x squared plus 4x
Mm-hmm.
plus 1.
Mm-hmm.
All under the radical, but I haven't distributed the minus yet. So far, so good? Cool. I'll swing it back over here. Now I'll distribute that minus. All right, minus 4x squared minus 4x minus 1. Any like terms in there? What do you think, Claire? Any like terms?
1.
I'll flatten this. Oh, the 1 minus 1. So now we're going to see why the back of the book was able to do just a tad. Because this one and that one, what?
0.
Vanish. Now you got a negative 4x squared minus 4x. So far, so good. Well, Claire, can we factor a number out of the 4s? A 4. Isn't 4 a perfect square?
Oh, and then they
Yep.
canceled out the 2 and
Yep.
the 4. Oh, okay.
So when I'm going to show the factor and they're like, oh, we got to factor out a 4 out of that, you get negative x squared minus x. Some of you are like, factor out the x. You can if you want. But it's really that 4 they're dealing with. It's really the 4. And then the square root of 4 is what? 2. 2 divided 2 is, so you can write this final answer as 1 over square root negative x squared minus x.
Would you take off points if we wrote, like if we didn't
Like that?
oil it?
I'm fine with that.
Okay,
I really am. I think it's good to do this though.
yeah.
You go, why? In case, you know, this was helpful to you some ways. You're like, well, if I do this, it helps me do a problem later on in calculus a little bit easier. That's totally fine.
Okay. Can you do 62 as well?
You bet. 62, same section, right?
Yeah.
All right. I like this. Arctan x squared minus x. Find the derivative. All right. Arctan. I love arctan because there's no radical. Carries.
Mm-hmm.
Cool. But hey, Claire, you're good to go there, right?
Yeah,
Good, dude.
the only thing I was worried about is I thought I did something, like I understood something incorrectly because I didn't get the answer that they had, but I wasn't sure if they like simplified it to something weird. But they did.
And I know you know how to do this. I know you know how to do this.
Yeah.
But it was there that they decided what?
Yeah, I was like.
That's a neat trick. You might find that very, what, the idea of taking out a 4, you might find yourself doing that more often, like in maybe Calc 2.
Okay.
You might. A couple problems. I'm trying to think in Calc 2 where it's like, yeah, you can just factor out the 4, put a 2 there. Count raise. All right, here, another one. 56. Find dy, is that right?
62.
Oh, way off. 62. F of x equals arctan x squared minus. Find derivative. All right, there's your g. There's your g. What's derivative of that?
2x minus 1.
2x minus 1. I'll put that up there. Chain rule. 2x minus 1. How do you call arctan's derivative?
1 plus
1
x,
over 1 plus.
x squared.
Yeah. And so in this case, 1 over like 1 plus g squared, where that's my g. So this over 1 plus all that. This one or this one? There's your g. Or your u. All this. Then what?
Square.
And we're done. But then, Kel, is that the answer in the back of the book?
No.
So they did something with the bottom, right? All right, let's play with this. Let's expand that. All right, I want, what's an x squared minus x? X squared minus x.
X to the power 4 minus 2x cubed plus x squared.
All right. All right, I'm gonna do that. 1 plus x to the 4th minus 2x cubed, we're foiling, plus x squared, right?
Mm-hmm.
And we get 2x minus 1 all over x to a 4th minus 2x cubed plus x squared plus 1. And you can look at that and wonder, can you factor anything out of the bottom? No. How'd the back book write it?
They're not in, that, the evens aren't that good.
Oh, they
I'll
have
let you know if
these.
I did it right.
Yeah, oh yeah. This is fine. This is fine, I did want you to look at it, Cal. You might say, well, maybe I can factor this by grouping and then cancel this. But you could check it out, when if you factor by grouping won't work, because you factor out x cubed, you'll be left with an x minus 2, and that doesn't match this. So I didn't want you to think you can factor by cubing. It's fine. Differentiated correctly, good job. And probably the funniest thing, everyone, most of the time in Calc 1, even Calc 2, you're just dealing with this guy. Just this lonely arctan x. And that derivative is just 1 over 1 plus x squared. Seriously. And then later on, I don't know, after July 4th, you and I will do the antiderivatives. And out of the blue, this will pop up. You've learned all these techniques, and that thing will just pop up in the middle of all these problems. And you go, wait a minute, and you go, oh yeah, that's the arctan. And you'll say this equals arctan x. The idea of going backwards. We always put a plus a constant there when we do it. And even, this is another thing, what if this had a 5? All you do is you throw the 5 out here, and you put an answer like that, because of the constant rule. Constant rule applies with the antiderivatives as well. So that's really what's going on, so you can see that. And it's a great one. Any others?
I had a question. It's not from the textbook, it's from a review book.
Yeah.
The problem was find the derivative of natural log of e to the x over e to the x minus 1.
All right, natural log of e to the x over e to the x minus 1, and it said find the derivative, right?
Yeah.
All right, let's do it. First of all, I'm looking at that thing. Do you know any log properties?
Yeah.
There's 3 ln properties. One of them is where you can move that power in front. And before I work that problem, you might find that helpful. So let's just review, pre-calc log properties. There's only 3. The first one is ln a over b. I can write that as natural log of a.
Minus-
Someone in here knows.
Minus ln.
Minus ln b. So you might find that property helpful in that problem. You might be looking at it now going, oh, I know how to do it now. So that's one thing. Might as well do all the other ones. Does anyone know what a times b is?
A plus.
ln a
Plus B.
plus ln b. The third property, everyone, of logs, if you got like an a to a c power, you can scoot that c where?
Front.
You can scoot it in the front. So these are just log properties. So you can write that as c natural log of a. But there's only 3. I don't think there's like 100. It's only three log properties. There you go. Some call that the quotient rule. I don't like that because there's a quotient rule for derivatives. So I don't want you to confuse yourself. Some call that the product rule for logs. But I don't want to confuse you because it's a product rule for derivatives. There you are. Hey, so I'm going to try that. I'm going to start this problem with what? Ln e x minus ln of e x minus 1. And I'm going to find this thing eventually. So I like your problem you got from the review book. Before we even go here, we can really light this neatly
1.
by these properties. So let's go over here. Can I move that power?
Mm-hmm.
E to the x now? Everyone's like, yep. Move that x to the front of ln of e. Before I do the derivative, what's the natural log of e?
1.
So let me get this, before I even start, it's like, that's just x. Natural log of e is 1. The natural log of e to the x is just x. So now I'm going to do it, everyone. Wow. Now let's differentiate y with respect to x. That's a simple what? Oh, that's a 1. But now, do you remember how to do these? We put this in the what? The denominator?
Mm-hmm.
And then chain rule, what's the derivative of e to the x minus 1?
E to the power x.
That'd be e to the x plus a 0, right? Is everyone okay with that? Remember how you do natural log derivatives? Factors there, then I multiply the derivatives, put it here. So this is the answer, but I imagine in that workbook, they got it in one fraction. So let's do common denominators, everyone. What would I have to multiply here?
E to the power x minus 1.
E to an x minus 1 all over. e to the x minus 1. And it looks like I get e to the x minus 1 minus e to the x all over e to an x minus 1. And sure enough, what cancels in the tops there? They subtract out, right, Claire? They're like e to the x minus e gone. So the final answer should see this in your workbook. I like your problem. That should be the derivative. There's nothing else we can do. Like we can't, no, that's it. That's the prettiest we can make it. Good job. I mean, there's other ways to do it. I just thought that was easier. Deal with the properties first. Get it clean. We got it here, and then you're like, okay. Okay, I'll work with that now. A good one. Very good. Any others? I'm looking at Amber. She got it from a workbook. It was a neat problem though, but these were helpful at the beginning. And then when we got to here, we were like, wait a minute. You can kind of move that X there. And that was just, before we even differentiated, we did 3 like rules of pre-calc before we even got started.
Oh, the ln and the e cancels out, so then it's just y equals x
Yep.
minus.
But then here, when we got to here, we're like, all right, now it's time to differentiate. That's a nice 1. And then this was the e dx minus 1 on the bottom, e dx. ln derivatives are great, aren't they? All right. Hey everyone, today, before we get into related rates, I still want to wrap up 3.7 and talk about that calculator tool. A lot of you are nifty with it, which is great. It's just sometimes you can avoid the old quadratic what? Formula. When you got to solve some quadratic equation, you're just like, I'm going to write it as a decimal anyway, why don't I use this tool? Key word is facilitate. It facilitates it. So I'll go back to that same problem you had before. It was in 3.7. It was number 9, right?